Hi, my name is David from Social Science 10C, and in this video I'm going to be showing you how to calculate an F statistic for a repeated measures ANOVA. Here is a repeated measures ANOVA question. A scientist that is studying factory workers thinks that exercise helps increase the number of widgets produced by each worker. To prove this, he takes a sample of 4 people and observes them over the course of 3 weeks. The first week is a baseline with no exercise, and the next 2 weeks are exercise weeks. Below is the data. Calculate the F statistic for a repeated measures ANOVA using the data. Show all your work, state the critical value, and come to a conclusion about exercise and widget production. The total sum of squares is 408. The first step to solving this problem is to calculate the mean of each column and each row. To do that, we add 50 plus 54 plus 55 divided by 3, and that'll give us 53. We do this for each row. I've already calculated all the means for each row, and the next step is to calculate the means for each column. 50 plus 53 plus 57 plus 60 divided by 4 equals 55. And now we do that for the next 2 columns. Now that you calculated the means for each row and all the columns, we're going to find our grand mean. And we do that by simply getting the mean of the total columns and rows. So to do that, we add 53 plus 57 plus 60 plus 66 divided by 4 equals 59. And that number 59 should also equal the mean of the row totals at the bottom. 55 plus 60 plus 62 equals 59. This is our grand mean, 59. The next step is to calculate the sum of squares between, which I've written down right here. To calculate that, we will multiply the number of subjects, which is 4 because we have 1, 2, 3, 4 subjects, and we'll multiply that by 55 minus 59. In other words, our mean for week 1, 55, minus our grand mean, 59. Then we have to square this number. We do the same for each week, and we add them all up. So we add 4 times 60 minus 59. This represents week 2. And then we do 4 times 62 minus 59. And that's for week 3. You calculate these out, and you should get 64 for week 1, 4 for week 2, and 36 for week 3. When you add them, you get 104. So your sum of squares between is 104. Next step is to calculate your sum of squares subject. To do that, we take the number of weeks, which is 3, and we multiply that out by the mean for subject number 1, which is 53, minus the grand mean, 59. And we square it. We're going to do the same for each subject and add it all up. So 3 times 57 minus 59 squared for subject number 2 plus 3 times 60 minus 59 squared for subject number 3 plus 3 times 66 minus 59 squared for subject number 4. When we multiply that out, we get 108 for subject 1, 12 for subject 2, 3 for subject 3, 147 for subject 4. We add them up, and we get 270 for sum of squares subject. Next step is to calculate your sum of squares error, and that's going to equal our total sum of squares, which is given to us in the question. It equals 408 minus sum of squares between and minus sum of squares subject, and we just calculated those out. So that comes out to be 408 minus 104 minus 270, and that equals 34. Our sum of squares error is 34. Next step is calculate our degrees of freedom. Calculating the degrees of freedom is really simple. I've already calculated them all out right here. What I did was to find the degrees of freedom between is the number of weeks minus 1. So 3 minus 1 equals 2. For degrees of freedom subject, it's number of subjects minus 1. That's 4 minus 1 equals 3. And to find our degrees of freedom error, it's simply those two answers right there multiplied. So 2 times 3 equals 6. Now we can calculate our F statistic. I've written down the formula for the F statistic. It's sum of squares between divided by degrees of freedom between divided over sum of squared error divided by degrees of freedom error. And we already have all those answers, so all we're going to do is plug them in. We get 104 divided by 2 all over 34 divided by 6. And that comes out to be 9.187. That's going to be your F statistic. To find the critical value, you're going to need an F table, and you're going to use these two numbers, the degrees of freedom between, which equals 2, and the degrees of freedom error, which equals 6. The degrees of freedom between is going to be the top number in the table, and the degrees of freedom error is going to be the number on the side. So it comes out to be, critical value comes out to be 5.14. Next and final step is to compare the F statistic with the critical value. This F statistics falls within the critical region, so that means that we're going to reject the null. What that means is that exercise does affect the widgets produced. And that's how you calculate a repeated measures ANOVA. Thank you for watching.